Ever wonder how your streaming service seems to know exactly what you'll love before you've even watched a single show? Or why your phone suggests the perfect song after just a few listens? It's all powered by recommender systems, those invisible algorithms working behind the scenes. But here's the catch. When there's no data to work with, like with a brand new user or a fresh product, traditional methods hit a wall. That's the cold start problem, and it's a massive hurdle in making recommendations feel truly personal. So how do we solve it? Let's dive into a groundbreaking approach called the Radial Neighborhood Smoothing Recommender System, RNE. Think of it as giving recommendation systems a superpower, the ability to guess what you'll like, even when there's barely anything to go on. Let's start with the basics. Most recommendation systems rely on two core techniques: matrix factorization and neighborhood-based methods. Matrix factorization works by decomposing user-item interactions into latent traits, like figuring out if someone prefers action movies or documentaries. But here's the thing, it's great for the big picture but can miss subtle patterns. On the flip side, neighborhood methods look at similar users or items, but they require overlapping data to function. If a new user hasn't rated anything, these methods freeze, like trying to guess a recipe with no ingredients. That's where RNE steps in. Instead of guessing hidden traits directly, it uses observed data, like the ratings you have given, to estimate similarities. Imagine figuring out a friend's taste by comparing their movie ratings to yours, even if you haven't seen the same films. RNE bridges the gap by creating a radial neighborhood, a map of connections that includes not just direct matches, but also indirect ones. It's like considering friends of friends or items that share partial similarities, creating a more nuanced network of connections. Here's the magic. RNE uses kernel regression to smooth out these relationships. Think of it as averaging recommendations from similar users or items, but with a twist. The weights are based on calculated distances in a hidden latent space. This space is like a secret code, where each user and item has a unique fingerprint. By measuring how close these fingerprints are, RNE can make smarter guesses, even when data is sparse. But how does this hold up in real-world tests? A recent study compared RNE to 5 other methods, like collaborative filtering, cfuser/cfitem, and math-based gap filling, softImpute, across datasets like MovieLens, Steam, and Jester. They used log transformations to normalize skewed data, split datasets into training test sets, and simulated cold start scenarios by randomly sampling users' items. The key metrics: RMSE, a measure of prediction accuracy, and null proportions, missing data. The results: RNE outperformed the competition in most cases. On datasets like MovieLens or Steam, it achieved the lowest error rates and minimal missing data. Even on trickier datasets like Jester, Jokes, it held its own. But the real win: in cold start scenarios, where there's no data at all, RNE still delivered surprisingly accurate predictions. While error rates increased slightly, missing data remained low, proving its adaptability in messy, real-world situations. Why does this matter? These algorithms power everything from healthcare predictions to social media feeds. By turning sparse, incomplete data into actionable insights, they help us make smarter decisions, whether it's choosing a movie or uncovering patterns in scientific research. Of course, no study is perfect. The researchers note they didn't account for factors like demographics or social networks, which could further refine results. But this work is a huge leap forward for recommendation systems, especially in data-scarce environments. So next time you get a perfect suggestion, remember, it's the result of math that's as clever as it is practical. If you want to dive deeper into the numbers or see the actual graphs, check the description. Stay curious, and I'll catch you in the next video.